All right, let's jump right in. Today, we're talking about an idea so big, so out there, it could completely flip your understanding of reality on its head. Imagine a theory that says everything you see, everything you are, time, space, matter, all of it, springs from the simple geometry of a single circle. So here's the thing. At the very core of modern physics, there's this massive problem, a total contradiction. We've got these two amazing theories, right? General relativity, which handles all the big stuff, galaxies, black holes, and then quantum mechanics, which deals with the super weird world of tiny particles. The problem? They can't agree on what time even is. Seriously. For Einstein's relativity, time is stretchy, it's personal. But for quantum mechanics, it's this rigid, universal ticking clock. They just don't match up, and they can't both be the final word. So that begs the question, right? What if this whole fight between our two best theories isn't the real story? What if it's just a clue, pointing to something much deeper, something we've been missing? A single, beautiful, geometric truth that could finally unify them both. Well, that's exactly where this idea of vector cosmology enters the picture. And it asks us to take everything we think we know and just throw it out the window. It all starts with one core, kind of mind-bending idea. The entire universe, it's just one single thing. Yeah, you heard that right. Forget all that stuff about atoms and quarks being the fundamental building blocks. This theory flips that completely on its head. It says the universe isn't made of trillions and trillions of tiny parts. No, the universe is one single, indivisible whole. All the different things we see around us, according to this, that's just an illusion. Okay, so what is this one thing? It's called the global pure state vector. Now, that sounds complicated, but hang with me. It's actually a pretty wild idea. Imagine a space, but not with 3 or 4 dimensions, but with infinite dimensions, and every single dimension represents a different possibility for the universe. Well, in this infinite space, our entire universe, every star, every planet, every moment from the Big Bang to right now, is represented by the position of a single solitary point. That one point isn't in the universe, that point is the universe. But you know, a point that just sits there forever? That's a boring, dead universe. For anything to happen, for change, for life, for time itself to flow, that point has to move. And here's the kicker. Its movement is controlled by one single, unbreakable law. It has a totally fixed, constant budget for how much it can change. You can think of it like the universe's master clock speed, or its total processing power. It's a hard limit. So, if the universe has this one fixed budget, the most important question is, how does it spend it? How does that budget get divided up? Because that division, that single decision, is what creates the entire reality we see and experience. And the theory says the very first thing that ever happened was a split. The total budget got divided into 2 categories. And get this, the rule it follows is one you learned in middle school, the Pythagorean theorem. A squared plus b squared equals c squared. That simple, ancient equation, it might just be the master code for the entire cosmos. So what are these 2 sides of the cosmic budget? Well, you've got external motion, which is exactly what it sounds like, moving through space. And then you have internal evolution. Now, this internal part is, well, it's everything else. It's the stuff that makes matter complex, it's what gives things mass, and this is the big one, it's what drives the forward flow of time itself. They're like 2 sides of the same coin, and they're always in a trade-off. You can't have more of one without giving up some of the other. And this is where it gets really cool, because it perfectly explains some really weird stuff. So picture an object that's just sitting still. It's at rest. It's not using any of its budget to move through space, right? So its entire budget, all 100%, is poured into internal evolution. What does that mean? It means its internal clock is ticking away at the absolute maximum speed possible. Okay, but what happens when that object starts moving? Well, to pay for that motion through space, it's got to take some budget from somewhere, and it takes it from its internal evolution. The budget gets split. And this is the punchline. Moving through space literally costs you time. Your internal clock has to slow down to pay the bill. Now let's push this all the way. Think about something moving at the speed of light, like a photon of light. It's spending every last drop, 100% of its cosmic budget just on moving. That means there's 0 budget left over for internal evolution. 0. Its internal clock has completely, totally stopped. From that photon's point of view, time doesn't even exist. So you see, Einstein's famous time dilation isn't some bizarre magic trick. It's just simple cosmic economics. You've run out of budget for time. So there are a few really good ways to think about this. Geometrically, it's a circle. Your total speed is constant and you're just changing how much is forward versus sideways. Computationally, think of a computer. It has a fixed clock speed and it has to share that power between moving data around and actually thinking about it. And my favorite one, economically, it's a zero-sum game. You've got a fixed pile of cash. You can either invest it in building things up, mass, complexity, or you can spend it on moving around. You just can't do both at full blast. Okay, so that's space and time, that first big split of the budget. But what about, well, stuff? Electrons, quarks, all the forces of nature. Where do they fit in? The answer is pretty elegant. That internal part of the budget, it gets split again and again and again. You see, that internal budget isn't just one simple pot of money. It's more like a waterfall, cascading down and branching out over and over. A chunk of it gets allocated to become mass. The rest of it, that gets split up even further to create the fundamental forces we see in the universe. The strong force that glues atoms together, the weak force that governs decay, and good old electromagnetism. And this gives us this incredible new way of looking at things. You know the standard model of particle physics, that big, messy chart of all the different particles? It's always seemed kind of random. But in this view, it's not a chaotic list at all. It's more like a precise origami manual for folding geometry itself. Let me give you a few examples. What's an electron? It's not a thing. It's a budget plan. It's a protocol that says, okay, I'm allocating this much budget to mass, this much to electromagnetism, and a little bit to the weak force. A quark? That's just a different investment strategy. It puts a huge chunk of its budget into the strong force. And a neutrino? It's the ultimate minimalist. It basically puts all its money into one stock, the weak force. See? Different particles are just different ways of spending the same cosmic money. All right, stick with me because now we're getting to the final piece of the puzzle. And honestly, this is the most mind-bending part of the whole theory. What if the reason these particles exist and are stable isn't just random chance? What if their very existence is written into the code of a fundamental constant of the universe? There's this really deep idea from physics called Levinson's theorem. And what it suggests is just, wow. It says that stable particles, the very stuff you're made of, aren't actually stuff at all. They are knots. Knots tied in the geometry of the universe itself. Think about tying a knot in a shoelace. The knot isn't made of anything different from the shoelace, right? It's just a stable shape of the shoelace. And the most important part? You can count those knots. And what number do we use to count these fundamental knots of reality? It's a number you've known your entire life. Pi. That's it. That's the punchline. Matter isn't a substance. Matter is a number. The math shows that for every stable particle to exist, the geometry of the universe has to twist around on itself by exactly pi. Creating a particle is literally just counting out another pi. The implication here is just staggering. I mean, think about it. If the existence of matter is just a direct result of the geometry of pi, then maybe everything is. Every physical law, every fundamental constant, our entire reality could just be a kind of holographic projection from the information encoded in that one single perfect shape, a circle. And that leaves us with one last really deep question to chew on. If the entire universe is encoded in the geometry of a circle, and time is just the act of tracing its edge, then what does that make us? Are we just along for the ride? Are we simply the part of the universe that evolved to be able to read its own infinite, beautiful code?